This is a video solution to the organic chemistry worksheet. This section is on the polymer. We start from question number 11. Now take note of these two acids given, lactic acid and glycolic acid. Lactic acid comes from the sour milk, occurs in the sour milk, and then the glycolic acid comes in the sugar cane. So actually these two acids are found in all this organic material that is being produced by living things, like milk produced from animal, and of course sugar cane from the plant. All right, so all these are natural occurring. They are not actually produced by chemical reactions out of the fossil fuel and so on, petroleum. So let's look at these two acids now here. So they're asking what are the functional groups present in both acids. So let's look for functional group. There is a hydroxyl and then carboxyl. Likewise for this, there's a hydroxyl, and this is carboxyl functional group. All right, so carboxyl functional group and hydroxyl functional group are present in both of the acid. Now name the salt when glycolic acid reacts with sodium carbonate and write the chemical equation. Now, glycolic, for example, ethanoic become ethanoate. So glycolic become glycolate. Okay, IC become ATE. So IC acid together like that. IC acid, the name will change to a salt which ends with ATE. Okay, so the metal will form the first part of the salt. So it's sodium glycolate. Sodium glycolate. You must learn how to write this name. Then the chemical equation. So you look at the formula here. So based on this structure, let's put into a condensed structural formula like this. HO from the left to the right. Then there's a CH2, which is here. And then there's a COOH. Alright, so we write this in the condensed structural formula so that I can easily show you that this hydrogen is being replaced by the sodium during the chemical reaction. So when you form the glycolate, this hydrogen ion is the only one that is being replaced by the metal ion to form the salt. So sodium comes in and then hydrogen comes out. So carbonate. So carbonate forms water and carbon dioxide. That's how you write this chemical equation. Alright, if you are not too sure, do consult your teacher. The next thing down here, this one is little bit more difficult. Draw the structural formula of the organic product formed when glycolic acid is heated under reflux with acidified manganate 7 ion. Now let's look at this acid down here. Let me remove all this first. Okay, so I'm going to bring this down for you to see more clearly. When the alcohol is being heated with oxidizing agent and form the acid. Now look carefully down here. This is already an acid functional group. It will not change. That's why it's here. This is the same. The next part will be this. Now remember, if you have alcohol, like for example ethanol, CH3 OH, it looks like this. So it's COH like that. CH3OH. This is the normal methanol. When you oxidize these to acid, what do you do when oxidize them? You remove this hydrogen and replace by a oxygen. So removal of hydrogen is oxidation. Addition of oxygen is also oxidation. Oh, sorry. So it's like that. So after removing the two hydrogen, you left with this, and you add oxygen. This will be the methanoic acid from methanol. So two hydrogen removed, put the oxygen here. So likewise, look carefully at this structure here. The H is to be removed, and then turn this into double bond O. So that's how you get this thing here. Okay, so this part, it become this. And then the OH is as usual. So the hydroxyl functional group has now been converted to a carboxyl. And you realize it's just COO, then COO, that's all. And this is the formula. Okay, structural formula. Now, when you draw a structural formula, preferably you show the bonds even in between this one here. All right. So it'll be good for you to show even here. So you can do this dash O dash H. And this is also dash O dash H. Show the full structural formula. Now this question here, draw when one molecule of glycolic acid and one molecule of lactic acid combine together, they form esters. So look carefully at the functional group. Okay, this is the two acid. I highlight here, this is a hydroxyl group, this is a carboxyl group, this is a hydroxyl group, carboxyl group from the two different acids. Now, to form the ester, you remove the OH from the acid functional group. And then you join to the other side after you remove the H from the hydroxyl functional group. So this is removed as H2O. You join the C double bond O to the O here, which I highlight in color to show you that this is this, the O is this, and the rest are remaining there. Now, how about the other one? Don't forget there's one more O here, one more OH here. I can join this to this side. Now, how does this structure become this? You know that these two bonds, okay, I'm going to draw this thing. This bond and this bond, they can flip position. In other words, these two functional group, they switch position in order to derive this one. But of course, you can draw this on top. You can draw the COOH horizontally here, and then you draw the O, the green color on top here. It's the same. So entire structure will go on top here. So basically, I remove the H from the O, the green color OH, and I remove the OH from this pink color COH and join here to the green color. That's how you join. But what happens is that this diagram basically is you swap this blue and the green, switch position. The blue go on top, green go to the side. So blue remain on top, the green go to the side, OH, and you remove the H and join to this C double bond O. You flip this structure, okay, laterally inverted, so that this OH go to this side, this COH go to this side. All right, so you basically remove, I use another color, I use a green color. You remove this, and you join from here to here, which is this. Okay, so this is how you draw this one. Now you can draw different combination as long as your one side, the hydroxyl, join to the carboxyl from the other side. So in other words, one is here, one is here. The structure may not be exactly like that, but it is fine, so long you join the correct functional group to the other one. Okay, so these are two answers. Okay, next one. They are reacted together to make material for soluble stitches. Okay, used in surgery. So it's like soluble threads that can dissolve by itself. So in this material molecule, each acid will be reacted to form a long chain polyester molecule. All right, and then it's used surgery to sew up the wounds inside the body. For example, in the internal organ, they use this to sew up. Over a period of time, the polyester undergo chemical reaction and breaks up, and then it will just break out and disappear. Now, what type of polymerization does glycolic acid and lactic acid undergo? Of course, it's called condensation polymerization. Now, even if you do a simple combination of these two, like 1-to-1 combine, to form this is called ester. Ester formation involves the removal of H2O. And because there are two functional groups in each molecule, so it can join from one molecule to the next one to form a long chain. That's why it's called condensation polymerization. So esterification itself is a condensation process already. So in this case, condensation polymerization. Can this polyester material break down naturally? Yes, because both monomers are made from natural substances. They are biodegradable, like milk, all right, like in the sugar cane. All these living things from living things are all biodegradable. So any living thing that die, they'll decompose completely. Okay, broken down by the bacteria in the air, in the soil, that decompose them totally into back to elements again and go back to environment. So they are actually biodegradable. Okay, so the keyword is that they are made from natural substances like milk and the sugarcane, which are biodegradable and therefore can be broken down naturally. Okay, next question, Kevlar. Question number 12. Now, Kevlar is a man-made polymer and used in bulletproof vests. All these structures you just need to recognize and apply your knowledge, your simple knowledge. Okay, don't have things too complicated. You always look for functional group that is familiar to you. Now, in this case, we can see that what kind of linkage is this? Okay, in simple, I write as CONH, CONH, and this is amide linkage. So this is a kind of polyamide linkage. If it's COO, then it's ester linkage, polyester. So start reaction that in the formation of this, to form this amide, to form the polyamide is of course condensation polymerization. Okay, you need to know two, right? One is either addition polymerization. When there's carbon-carbon double bond in a monomer, you can do addition polymerization. If not, then you must look for molecule with two functional group, and then they can do condensation polymerization. So what I do is that you have to write the monomer, right? Very simple. Look at this one. I'll cut exactly in the middle of the linkage here. Cut in the middle. And one side will be this. The other side will be this. When it's NH, you join a H back. H back. When C double bond O, whenever you C double bond O, you join OH. You join OH. And these two are the monomer used to make the Kevlar. Okay, copy exactly, and then you just add on to two sides. If it's let's say a C, the O, it's a single O only, then you just put a H at the back. Go back to the hydroxyl functional group. Now, name another synthetic polymer have similar linkage. Of course, polyamide. Nylon is another polyamide. Okay, question number 13. Acrylamide can be polymerized to obtain a polymer. So this is the structure of the monomer. And look carefully here. I have one functional group, which is the amine NH2 functional group. And this one, you don't have to worry about this. You look at this. This is a carbon-carbon double bond. So you can do a polymer, okay, out of this. This is an unsaturated monomer. So I can do a addition polymerization when there's carbon-carbon double bond. So name is, of course, if this is called acrylamide, then you just put the word poly in front. Polyacrylamide. Okay. Now, whatever name they give to you in monomer, just put a poly in front to make the polymer. Name the type of polymerization take place and explain why. Why does this undergo the kind of polymerization? Of course, answer is addition polymerization. And the monomer, the reason why we choose the addition polymerization and not condensation, because in condensation, you need to have two functional group per monomer. All right, there must be a loss of a small molecule like water during the process of joining the monomer together. However, down here, we only have carbon-carbon double bond, and we know that it can undergo addition reaction. So reason is that it contains carbon-carbon double bond, which will join to other monomers covalently to form the polymer. So please take note of it, covalent bonding. All right, so there's the existence of a carbon-carbon double bond that will join to other monomer covalently to form polymer. Please memorize some of these key phrases in order to score well for your exam. All right, you're expected to know. Now, if I want to draw the polymer structure, what do? You make sure that the two sides don't have anything here. Okay, I highlight here. This one must be blank, this one must be blank. Why? Because I'm going to open up my single bond on the two sides. Okay, so I change the double bond in center to single bond, and the two sides I just draw the bond out, which is like this. Now this CONH2 is written here on top. You can draw exactly the structure on top, no harm. Alright, usually I prefer to draw exactly whatever they give you, I draw exactly on top. But make sure it's within the square bracket when you draw the polymer. Alright, so this one can be drawn in full. This one draw in full inside. And you put bracket, make sure that the bond that opens on two sides sticks out, and put the N. Okay, where N is a large number. If you do know, N is a large number. How large? Thousands and tens of thousands and so on. Okay, it's a large number. Now, next one. Polymer is biologically inert and non-biodegradable. Explain the term non-biodegradable and describe one problem which this property causes. The word non-biodegradable means they cannot be broken down naturally by natural process. So, cannot be broken down by natural biological processes, or can it be broken down naturally by microorganisms such as bacteria in the soil. And because of unable to break down naturally by these microorganisms, it will be lasting there forever. So it causes land pollution as they cannot be broken down and lead up to build up waste. Now you have to explain why land pollution. All right. If it become like, if you go onto the land and make it beautiful, of course you cannot say that it's pollution, right? But because it is left on the land and it build up of the waste. Imagine rubbish stacking up and then not able to break down, not able to disappear, it stay there permanently for hundreds of years. Of course, building out of this waste is a land pollution. All right. Okay, next one. When 50 tons of acrylamide polymerized, 36 tons of polymer were obtained. The percentage U. Now, the expected polymer is 50 ton because in addition polymerization, there's no loss of molecule. There's no loss of molecule means all the monomer must convert and become part of the polymer. So if I give 50 ton by right, you should have 50 ton, but you only get 36. So the actual one over the theoretical maximum is called percentage U. So I only have 36 tons, but I should be producing 50 tons. So 36 out of 50 is only 72% U. All right. If you put the other way around and the percentage exceeds 100%, you just turn it over. Okay, usually you get it right. Anyway, two number only. What can you do? 36 over 50 or 50 over 36. The percentage U must be lower than 100%. Okay. Next one. Nylon is a generic name for synthetic condensation polymer with repeating amide group. So this is one of nylon, nylon 66. Explain how a condensation polymer is formed. All this like, how does addition polymer, condensation polymer, all these are theory that you can memorize. So condensation polymers are formed when monomers with two reactive functional groups. Remember I mentioned a few times, there must be two functional groups. One functional group doesn't work. All right, it must be on both sides. Two functional group, two reactive functional group. Now, why do they say reactive? Because the hydrocarbon group in the center is the unreactive hydrocarbon group in the center. They don't take part in reaction. And those that take part in reaction, of course, called reactive functional group, join together covalently. Again, the word covalently we mentioned previously. Even in addition polymerization, the carbon-carbon double bond, right, allows the carbon, okay, to join to the other carbons using covalent bond, covalently. So down here, we emphasize there's a loss of small molecules such as water, and this is very important. So how does it happen is that the condensation polymer form when two monomer with two reactive functional group join together covalently with the loss of small molecules such as water. And then you ask to draw the monomer. So look at this thing here. I'm going to pull out the polymer. If you look carefully here, so in between, and this is a monomer. So the NH is actually here, this one. All right, and then I just put a H on both sides. The bond, I join the H, join by H. So originally there was a H. And take note, inside is C2H6. CH26, sorry. This one must copy exactly. Next one is this side, C double bond O. It must be the acid. So I put back OH. One side, the other side put OH. Center must give back the same. Don't write wrongly. CH2 bracket 4. And this is the unreactive hydrocarbon group. And sometimes in the question, it is given as a shaded box. Shaded box actually shows only the one I'm not interested in. We're not interested in the hydrocarbon group in the center there because they are not reacting. Okay, but still must be written correctly. Okay, so that's all for these two monomer. Okay, next question. Styrene butadiene rubber is a synthetic rubber produced by polymerizing a mixture of monomer styrene and butadiene. Now look at these two down here. You realize that the carbon-carbon double bond is here. Carbon-carbon double bond, there are two of them here. Right. So when you do add them together, when you do addition polymerization, you have to convert this carbon-carbon double bond to single bond and join on to the next one. But there are two here. So I will just do with one of them. All right. One of them. So what is meant by polyunsaturated? Polyunsaturated. Now down here I can show you, right? More than one carbon-carbon double bond. Okay, you put all triple bond, that'd be good. Okay, but at least you must say that based on this explanation here, yes, more than one carbon-carbon double bond. Now, this polymer is formed from styrene and butadiene. So styrene is here, butadiene is here. Now I need to break up this carbon-carbon double bond to form single bond. So you realize that this C joined to the C, these are the two C's here. All right, I highlight this. These are the two C's here. Originally, it was a double bond in between, but now I form single bond on two sides. The other one comes from this. Okay, I want to highlight this part. This one. This one is actually this. You realize that this double bond, I break it to form one single bond here, one single bond there, one join to the styrene, one join to the next styrene, next molecule. This one is just here. It does not change. Leave it. All right. Just think simple and leave it like that. Okay. Now, this polymer has a range between the mass between 13,000 to 20,000. So how many of these repeat unit do we have? So first of all, let's find the repeat unit. The repeat unit is all this actually down here. Based on the formula here, look at this. This is C8H8. So the styrene is C8H8. And the other one, butadiene, is C4, 4 carbon, and 6 hydrogen. C4H6. All right. So because we do not know what's inside this ring, the benzene ring structure, but we know that the whole formula is C8H8. And the other one is C4H6 because we can count C4, 6 hydrogen around it. So add together, this repeat unit has C12H14. And that's the reason why the MR, the repeating unit, is this. Each carbon is 12. Okay, this is carbon. I highlight for you this carbon. Carbon times 12 plus 14 because each hydrogen is 1. So total is 158. So 158 down here is each repeat unit is 158. Then how many repeat can I have if I have 13,000? So I take 13,000 divided 158 is 82.3. Exactly 82.3 to be 13,000. And then 20,000 divided by 158, exactly 126.6 to be 20,000. But we know that repeat unit cannot be cut off, right? Must be entire repeat unit. So in order to be at least 13,000, I must round up the number. I must round up this number to 83. If you take 82 times 158, okay, let's try. 82 times 158, it gave me 82 times 158. It gives me 12956. And this is short for you need 13,000 minimum, so this one is out of range. So can I use 82? You must round up because minimum is 13,000, so 12965 is not enough. So you round to the next number. 83 will be 13,000 and above. Okay. Likewise, for 20,000 divide this is 126.6. Now, if we round to 127, naturally you want to round up, right? Because 0.6, so it's 127. But if you multiply by 158, 127 times 158, you will get 20,066. It exceeded. But we want only up to 20,000 because average somewhere in between Alright, so we cannot use the 127, you can use up to 126 only because 127 will be out of the range. So in this case, our range is 83 to 126. Alright, so common mistakes will be 82 to 127. They round now the 3, they round up to 6, and then mathematically it sounds correct, but it'll be out of range. So answer is this. Take note. Okay, you need to understand this question. Right. Butadiene can be made by cracking butane in a cracking tower. So basically cracking is very simple. The butane and then become butadiene. Butadiene, we know we calculated out C4H6. Yeah. And therefore, you know that it's hydrogen H2H2. There's no other way to write it because there's no carbon here. The carbon is 4 only on each side. So there's no carbon. So you only have hydrogen. And you know that it's either a hydrocarbon like alkane, or hydrogen can be a product also. So to balance equation, put a 2 here just nice because I need 4H. Now the next question now here, you want to add hydrogen is added to a sample of styrene. Now styrene is here. I'm going to add hydrogen to this. Isn't it the structure looks like this on top? If I add hydrogen on one side and the other side, answer is just like that. So these are the hydrogen that's being added on the two sides after opening out the double bond in the center. Alright, draw exactly back the structure. A hexagon with a circle in the center. You don't only learn more details in A level, but just draw exactly what they give to you. All right, I think we come to the end soon. So next question number 15. Ethanol can be made from glucose by fermentation, and of course you require what? Yeast. All right, it will give you the enzyme to ferment glucose. Why pure ethanol cannot be obtained in this process? Now you know that in glucose there's water and glucose, right? So when ethanol is being produced, it's only up to about 15% concentration. And ethanol is soluble inside the glucose solution. So out of the whole concentration is only about 15%. And of course, one of the reason is because the enzyme, the yeast will die, the enzyme will be destroyed when, I mean, the yeast will be killed anyway, when the concentration is too high. You know that alcohol is used as antiseptic. Like for example, if you use 75% alcohol, it'll be a strong antiseptic and can kill virus or bacteria. That's why we use alcohol wipe during the COVID, uh, the the pandemic at time. So what happened is that alcohol, when reach 15%, you kill the yeast, which is a living organism, and so once it's died, it dead already. There's no way to produce more. All right. So when it's 15% concentration is enough to kill the yeast. Now, why air should not be allowed? Because when air goes in, ethanol can be oxidized by air, oxygen in air to form ethanol acid. It turns sour. It turns sour. In fact, this is a process to produce vinegar. Ethanol acid is vinegar. To produce vinegar, they actually ferment rice. They cook the rice, which contains carbo. You put the yeast, you ferment it to ethanol, and then you stir the fermented, okay, fermented the rice, and exposed to oxygen in air, and then further oxidize it to ethanol acid, which is vinegar. That's how they make vinegar, okay, from the rice itself. So just take note, it can be oxidized by air. Okay, and then this one is the equation. State symbol, take note. Preparation of ethanol by this method. So glucose will turn into ethanol plus carbon dioxide. Remember, carbon dioxide is always given out. Okay, this is the structure of ethane 1,2-diol. Looks like ethane structure, but there are two alcohols, so it's diol. So a new compound form when this is oxidized. Obviously, when it's oxidized, you will form acid. Remember just now when you oxidize, what do? You remove the hydrogen, right? So what you do is you need to remove the hydrogen, and turn it double bond O. Likewise, remove hydrogen, turn a double bond O. So that's how you form the acid. So what is a homologous series it belongs to? Of course, when this is oxidized, you will turn into carboxylic acid functional group. Yes, carboxyl group. Now this is the structure here. Yeah, this is the polymer. Okay, you want to find the monomer, there's acid. The dicarboxylic acid monomer. So you cut between the ester, and you see that there's CO, CO. In other words, I'm going to join a OH here, join by the OH. And here I also join by the OH. And this give me the monomer for the diacid. All right. The other side, actually, if you realize, this side is diol. O, if you join by a H, O, you join by a H, it become a diol. That's the other monomer. Okay, identify one problem that comes to use of polyester. This is always the same kind of question. It's about non-biodegradable. If it's non-biodegradable, cannot be broken down naturally. Cannot be broken down naturally. Okay, let me write this word. By organisms such as bacteria, and therefore results in land pollution due to build out of waste. Okay, memorize the phrase properly. This is a very good phrase for you to remember. Cannot be broken down naturally by microorganism. Okay, then such as bacteria result in land pollution due to build out of the waste. So accumulation forms the pollution. Okay, next one. Just now we talked about condensation polymerization, right? So now we talk about addition polymerization. So this worksheet actually helps to bring you through certain factual things like what's the meaning of condensation, addition polymerization, and so on. So addition polymerization is when unsaturated monomer join together. Keyword unsaturated, join together covalently. Now remember this, join together covalently without losing any molecules or atom. Nothing is lost. All right, so if it's condensation with the loss of a small molecule, there's a difference. So structure of polymer that obtain and name this polymer. Now, for example, in this case, we're talking about let me see, okay, draw a structure of octane and this one. Okay, so down here we're talking about, did you say about propene? No, never mind. Okay, so this is a propene structure and this is polypropene. All right, polypropene. This is a one of a kind of plastic material. Okay,